guys, Eamonn Boyle here from Instill Software. Some people are intimidated by functional programming, but I want to show you how we can employ basic functional techniques in our everyday jobs to solve simple problems. And I'm going to show you it in Java, C Sharp, and JavaScript. Let's go! Okay, so here I am in IntelliJ, and I'm starting with Java. I've got a basic immutable class here. Okay, so we've got some fields which are private final, and we're only exposing the getters. So this is an immutable type representing an employee. Here I've got a collection of employees. I'm just using the as list to quickly create a collection of some of these objects. And what I want to do, what I want to solve, is just get the average salary of people in engineering. Okay, so it's a pretty basic algorithm. I'm just doing a for loop. I'm just doing an if to test the employees to see are they in the engineering department, and if they are, I'm aggregating a total, so I'm adding up a total of that employee's salary and counting the number of engineers that meet that criteria, and then at the end I'm just getting the average by dividing the total by the number. So pretty basic algorithm, but quite often a lot of what we're doing loops, we're doing ifs, we're testing some property of an element, then taking some other property of an entity and doing something with it, either bringing them together into a resulting collection to do more work on, or maybe reducing that collection, that filtered collection, down to some end result. Okay, so these are really common operations we do, and if we can employ functional techniques, this becomes a lot more succinct. We write declaratively, we say what we want to do without actually saying how to do it. We push the iteration internal into the functional libraries, and it makes our life a lot easier. So with Java, we got these capabilities with Java 8 in the form of streams. Okay, so what I can do is I can create a second average variable, and I'm going to try and calculate it in one operation using functional techniques. So I start off with my employees, and the first thing I need to do is construct a stream from that. So when I have the stream, now I have access to all of my functional words here. I have all of my functional methods, my toolkit. Okay, so with the stream, I can say, will filter me out the ones that are in the engineering department. Okay, so this will require a function which is going to take in one input, which is the one of the elements within our stream, and then returns true or false. And if it returns true, that means I want it in my end result. So I filter from the stream the ones where the department of the employee is equal to engineering. Okay, so now anything I do from here on is on a stream of employees within the engineering department. Then I can say map the employee. I don't want to deal with the employee. I actually want to deal with the salary of the employee. I want to get the salaries out so that I can do a reduction on all of those salary values. So I can say map to the employee's salary. Okay, now I have to do something slightly different here because we don't have reified generics in Java over primitive types. I actually have to say that I'm not just doing a basic map, I'm mapping to double. Okay, and now what I have is I don't have a basic stream, a stream of objects. I've now got a double stream. And with a double stream, I could do a reduction and do an operation to take all the values and compress them down. But the double stream actually has a built-in average. So that will pull out the average. Okay? Not quite finished yet. You can see here that it's red. The reason being that my list, my collection may be empty. And in that case, the average may not make sense. So we have to tell the system what to do in the case where it's empty. Okay, so what we're actually getting back here, if we hover over, what we're actually getting back, if you can see there, is an optional double. Okay, so the value that comes back here either has a value or it doesn't. So what I can do is I can say or else and give it the value whenever it doesn't, when the collection is empty and there is no average value, and I can just say 0. So if the collection is empty, I will get 0 back. Okay, and there you have it. Now it's a little bit of a learning curve if you aren't familiar with these, but once you build up this vocabulary and you become comfortable with these terms, it means you can really write things declaratively. So take the employees, filter out the engineering, map from their salary, and get me the average. But if the collection is empty, return me 0. Okay, and it just avoids any typos, any simple basic mistakes as we write reams and reams of this code. And it's not just for collecting averages. A lot of our work is loops, ifs, filtering, mapping, these sorts of operations. Okay, and one additional tidy up I'll do is that because we're saying when we're mapping to the double, we're mapping out the salary, we're just saying take the item and call its get salary method. What I can do is I can do I can put in a method reference instead. Okay, and IntelliJ will actually help me here. I can just do Alt and Enter, and you can see here that we're saying whatever the item is, call its get salary method. Okay, so it's even more succinct. And that's it for Java. So here we are in Visual Studio, and we're going to do the exact same thing in C Sharp. I love C Sharp. I think it's a great language. It allows us to write things succinctly, but it's a really powerful language as well. So we've got our employee class as before. It's really succinct because we're making use of auto properties here. They've only got getters, so this is an immutable class, but really neat way of writing it. We're using our collection of employees again. This is what we're going to operate on. And this time we're not using a list object, but we're going to use just a straight array. And again, we've got this array initializer, which is really succinct in C Sharp. We've got type inference, so even though we're strongly typed here, this is an array of employees. A lot of it's inferred by the compiler, so it's really neat. And then we've got our algorithm as before, and we're going to solve this now functionally. Functional programming in C Sharp is really exposed through LINQ, Language Integrated Query. Now this was brought in to allow us to do SQL-like operations on collections of objects, some data structures. So we could do things like select from where using just object collections. But more than that, it gives us our functional toolkit so we can solve problems in a fluent syntax using our functional operations. Now we have to do a little translation in our head from our standard terminology to the LINQ terminology. So when we think of filtering, we have to say where in LINQ. When we think of mapping, we have to say select in LINQ. Okay, when we think of reduction, we have to say aggregate in LINQ. But if you can get past that little translation, the syntax is really powerful and allows us to write really succinct code. So here I'm going to calculate our average as before. Okay, I'm going to work on the array of employees, and I'm going to do a where. I'm going to say where the department is engineering. Okay, so we have to say where instead of filter, but it's basically the same thing. We've got a lambda here using equals instead of hyphen as it is in Java. And you'll notice that we're able to operate this where directly on the array. Now what happened is they didn't go back and modify the array type. LINQ allows us to work on anything that implements IEnumerable. Okay, so that's arrays, lists, dictionaries, and our own types. If we implement this IEnumerable interface, then we can use LINQ. And all IEnumerable exposes is a way for us to iterate through a data structure. Okay, and the reason that they can do this, the way that they implemented it is using something called extension methods. And it's a really cool feature of C Sharp that allows us to write static methods somewhere, and then through syntactic sugar we can call them on an object as if it was a member of the object. So it looks like where is a member of employees, but it's not really. It's a static method, and employees is actually getting passed in as one of the parameters, but we don't have to write it that way. We can write it really fluently like this. So we've got our employees within engineering, so now we can map to their salary or select the salary. And because C Sharp we've got reified generics, even over primitives, over value types, what we're operating on now is an enumerable of double. Okay, so we're not doing any boxing or anything here, which makes it really powerful and really performant as well. And what I can do is I can just get the average. And that's it for C Sharp. Because the designers of LINQ said that, well, rather than go for an optional here with the average, if the collection is empty, I'm just going to default to 0. Okay, which makes sense for most cases anyway. You can obviously implement your own optional types, and we've got nullable types, and in F Sharp we have optionals. But here, this is a really sensible default and allows us to write our algorithm super succinctly. So it's only, it's 3 lines compared to all of this. Okay, and we can use this in our day-to-day programming for solving all sorts of things, because a lot of what we're doing is we're just doing some basic iteration, some basic selection. That's really a lot of what we do when we're defining business rules. And through LINQ and functional programming, it is really, really succinct, really neat. Okay, here we are in JavaScript, and we can even use our functional techniques in JavaScript. Out of the box, the collections, the arrays in JavaScript support functional techniques, so we can do filtering, we can do mapping, we can do reductions, we can do something for every element, we can use some of these capabilities. But if we want a more extensive range of operations, then we need to pull in a library. And the main one in JavaScript space is underscore, and it's a API equivalent Lodash, which gives us some additional features as well. So I've just pulled in Lodash, okay, which is accessed through the single underscore operator, but I'll do some of it using ES6 capabilities. So I'm using ES6 capabilities here to create my employee class. I'm using let to create my block scoped local variables. And let's go ahead and start to calculate our average. So I can operate on my employees directly, and you can see here I've got quite a few functional operations available to me. So I'm going to use filter. I'm going to use the arrow notation to create an inline function, which is going to be our predicate for our filter. I'm going to say, give me the employees filter for the ones that are in the engineering department. Okay. Then from those employees, map to their salary. Okay. And that's as far as I can get to get a collection of the filtered salaries. I could do reductions to do some more things, to do totals and things like that. But what I'm going to do now is I'm going to pull in the Lodash library, and I'm going to ask it to give me the mean of this collection. Within Lodash, you have access to lots of different functional operations that we can do. We can pluck out fields, we can find items, we can do all of these things that we can do in a lot of the other languages now. Okay, I hope you found that useful, and you'll maybe employ some of these techniques in your everyday programming from now on. If you liked it, please click like and subscribe, and if you'd like to see videos on any other topics, feel free to leave some comments below. Thanks, and see you again.